As a materials scientist, I've spent a career working in and visiting manufacturing facilities of all types. Aerospace, automotive, consumer, and industrial products. It's endlessly fascinating to learn about how the things that we use and touch every day are made. Automobiles make up a huge portion of the manufacturing landscape in the United States. I've heard statistics to the effect that about 1 out of every 10 jobs in the US is related to automobiles in one way or another. An important characteristic of automobile manufacturing is that it's distributed over a really wide geographic area. Parts and subassemblies are sometimes made a continent away of where they end up being used. Many automotive components spend a lot of time in shipping and storage prior to assembly. Automotive windshields are a case in point, and they have a fascinating history all by themselves. It's hard to believe that they started out being made of plate glass. It took a few highly publicized, gruesome accidents with shattering glass to motivate the invention of laminated safety glass sometime in the early 20th century. In modern automobiles, windshields are bonded into the car body, generally with urethane adhesive. They actually form the structural element of the automobile. This means that they are used as part of the design to stiffen the whole structure, not just keep out wind and rain. And this is part of the reason why we see windshields getting shorter these days. Less glass means that the cars are even stiffer and more crash resistant. This underscores the importance of a reliable bonding of the windshield into the car body. If the bond is substandard, not only can water or air leak into the car, but the entire vehicle becomes more flexible. This compromises the way it drives, and it compromises the way it responds to a crash. Most bonding issues get caught in the manufacturing process long before the cars ever leave the plant. Not all, though. Reviewing recall data for the past few years illustrates the problems repeatedly crop up in windshield bombing operations. Several major manufacturers, both foreign and domestic, have had major recalls of cars made in the past few years due to windshields debombing. In some cases, these windshields become airborne during accidents. Windshield installation is conceptually simple. You just carefully apply the adhesive to the precise area of the windshield and the car body, install the windshield, hold it in place while the adhesive sets. It sounds simple, but the devil's in the details. Successful adhesive bonding depends on applying the adhesive to a clean surface. The problem here arises in the definition of clean, which unfortunately varies from person to person and from manufacturing facility to manufacturing facility. And cleanliness is really something ephemeral. It changes with time. When glass is freshly cast from the mill, it has a remarkably clean surface, actually one of the cleanest surfaces that we can create. Chemists understand that clean means reactive. And if you get your adhesive or sealant onto this fresh, clean surface, it will react with the surface to establish great adhesion. However, the same characteristics that make a fresh glass surface adhere well to an adhesive make it adhere really well to other substances, such as any kind of contaminant that might be present in the environment. So unless we're making the glass in a clean room environment, the surface will rapidly absorb whatever's in the environment to form a thin, invisible film of contaminants. These contaminants tie up any reactive sites on the surface, and they effectively hide the glass surface from contact with the adhesive. So here's an example. We visited a major automotive glass manufacturer here in the Midwest that supplies glass to most of the major automotive manufacturers, as well as the aftermarket. Walking along the manufacturing line and monitoring the cleanliness of the glass surface using water contact angle measurements, we could see the cleanliness changing measurably with time and with handling. By the time the windshields were complete and ready for shipping, the surfaces were measurably less clean than at the beginning, and they were less reactive than when they started. They were certainly still clean enough for successful bonding, but the measurements served to underscore the sensitivity of the glass surface cleanliness. But windshields aren't bonded at that point. They're created, and then they get shipped via truck to factories or warehouses where they can sit for days or weeks prior to installation. If they're going overseas, they may sit in a ship's hold for a month or more prior to installation. And none of these changes in surface properties that are occurring during this wait time are visible to the eye. It takes measurement techniques that are sensitive to the chemical composition of the surface to detect these properties. This story, where a product's performance depends on adhesion, and adhesion depends on surface properties that are not visible to the eye, isn't unique to automotive windshields, however. We see it time and time again across industries, whether it's bonding, painting, sealing, or coating. Surface preparation and maintaining that prepared surface is crucial for ensuring optimal performance. The solution to these issues is twofold. First, we have to recognize how vital surface properties are to adhesion. And second, we have to use reliable measuring tools to monitor and control surface quality in real time. This combination helps ensure consistent high-performance bonding and prevents the kind of failures that can lead to bigger, costly problems down the line.